Welcome to the deep dive. Today we are really zeroing in on a single, very specialized piece of security hardware,
Yep.
the NTI E-PBD-DO90 dual photobeam detector. Our mission is pretty simple. We're going to cut through the specs and figure out what engineering choices make this kind of perimeter hardware actually reliable.
And reliability is everything here, right? I mean,
Yeah.
this is your first line of defense.
Exactly.
The base model, the E-PBD-DO90, it's about $162, and it gives you some serious range, 190 feet indoors, 90 feet outdoors. But you're not just paying for distance. You're paying for it to work when, things get chaotic.
Okay, let's unpack that idea of reliability. The first thing that jumps out at me from the spec sheet is the use of twin infrared beams. My first thought is, well, doesn't that just double the complexity, double the potential points of failure? Why two beams?
That's the core trade-off, and it's all about fighting false alarms. A single beam can be broken by anything. I mean, a large bird flies past, some heavy snow.
All falling leaf, even.
A falling leaf, exactly. With the lensed optics and the dual beams, the logic requires that both beams get broken at the same time.
Ah, okay.
And that gives it fantastic immunity to what we call, nuisance tripping.
And the environmental specs on this thing, I mean, it's built to take a real beating. It has an anti-frost system built right in.
Yeah, the case itself is weatherproof and filters sunlight.
Right, and the operating range is huge. It goes from -13 Fahrenheit all the way up to 131 Fahrenheit. It's built to not quit no matter what climate you put it in.
But all that ruggedness, it kind of brings up a huge installation challenge, doesn't it?
Oh, absolutely. I was just thinking that. How in the world do you align an invisible beam across 90 feet perfectly? It sounds like a complete nightmare for the installer.
Well, they solved that with a really brilliant feature. It has a built-in laser beam alignment system.
Okay, let's translate that for a second. It's a 650 nanometer wavelength. So for everyone listening, that's just a visible red laser, correct?
Yeah. That's it, a nice bright red dot. So instead of just squinting at a signal strength meter, you have a physical, visible marker to get that perfect alignment.
That has to save untold hours on setup.
Oh, for sure. And once it's aligned, it needs to talk to the main system. In this case, that's the Indorome UX ecosystem.
Which is sort of the central brain, right? It takes that simple alert from the detector and turns it into useful data.
Exactly.
And the connectivity options look pretty flexible. It seems like you can use standard 22-gauge wire for like a basic digital input, or you can run it over COF5 or Cat6 cable to an RJ45 port.
Right, which means it can slot into older legacy alarm systems just as easily as a modern network infrastructure.
So it's scalable.
Precisely. And that scalability is really interesting. We've been talking about the base model, but the high-end version, the E-PBD-DO390, that gives you coverage up to 790 feet outdoors.
Wow.
But here's the fascinating part, the power draw. The base model pulls a max of 64 milliamps. The top-tier model, which covers almost 9 times the distance, only draws 88 milliamps.
That's a tiny jump. That's incredibly efficient.
It is. It means you don't have to completely re-engineer your power supply just to get more range.
So it's really that combination of detailed engineering, the reliable twin beams, the smart installation features like that laser. That's what makes it so valuable. It's built not just to work, but to not create those constant headache-inducing false alarms.
Yeah, and that leads me to a final sort of provocative thought for you to consider. NTI also makes other specialized sensors. For example, a carbon monoxide detector, the ECMD, that's $290.
Okay.
But then they make a highly specific hydrogen sulfide detector, the EH2S, for $1,210.
Wow, that's a huge price difference.
It is. So given that our Photobeam is $162, what does that massive price variation really suggest? What does it tell you about the complexity, the manufacturing, and maybe the criticality of what each of these different sensors is designed to protect?
Definitely something to mull over. Thanks for joining us for this deep dive.